Hello everyone, welcome back to BC Calculus. We're still in lesson 37 where we're still talking about parametric equations. The last thing that I need to cover in this lesson is how to find arc length using parametric curves. I just want to refresh your memory really quickly that if you were looking at a rectangular coordinate, you had the arc length as a to b. And remember, it was just going to be the integration of 1 plus your derivative of your function for y dx. And the reason why this happened is because dx over dx just simplifies down to 1. So that's why this works. So the only difference here is that you're going to take the derivative of your x function with respect to t, and then you're going to take the derivative of your y function with respect to t. So that's exactly what's, I think it's much nicer to write it like this so you guys can see what it is. So we're going to take the derivative of x with respect to t and then the derivative of y. And then we're going to be giving you the bounds. So this is actually pretty awesome to do. So dx with respect to t is just going to be 1 over t. And again, it's with respect to t, so we don't have to do any implicit stuff here at all. And then dy with respect to t is just going to be 2t. So arc length for this problem, the arc length is going to be, and I'm going to call this L, is going to be equal to, well, we're given 1 to 2. And this is usually given to you. And remember, guys, when you do the problem, most of the times these are going to be calculated problems. So we're going to take 1 over t, you want to square it, plus 2t, you want to square it, dt. And then you use your calculator and you're going to get 3.0913. And that is as challenging as these problems are going to get. So for example, number 14, we want to find the arc length of these two functions on the interval from, and again, I can automatically go from pi over 2 to 3 pi over 2. So that's pretty awesome that we do it that way. dx with respect to t is going to be equal to the derivative of cosine. It's going to be negative sine of 2t, and then we're going to multiply by 2. The beautiful thing about this is that when we square these, the sign doesn't actually matter, right? So you want to look at, make sure your work in your problem is correct. But if you mess up a negative, then it's going to be okay because you're squaring it anyways. This is always going to be positive. And then your dy dt is going to be the derivative of sine, which is going to be cosine of t. And so we're going to do plus, and we're going to do cosine of t quantity squared dt. And we plug this into our graphing calculator as 4.647. So it's not challenging. This is, again, our nice little cool down on our lesson here. So last one for arc length, we're going to integrate from 0 to 2 pi. Sometimes our variables are just our constants are variables, so it's a and b. So our derivative of x with respect to time. And sometimes, guys, if you want to do dy over dt first and then dx, and because we're adding them together, a plus b is the same thing as b plus a. So some students like to do dy over dt to just constantly remember that when you're taking a derivative, you want to do dy over dt first and then dx over dt second. But in this case, it doesn't matter, so I'm just going to keep it this way. So we get that the derivative of this problem is going to be negative a sine of t. And then the derivative with y with respect to t is going to be just b cosine of t. So in one of our shortest videos we're going to do here, it's going to be negative a sine of t quantity squared plus b cosine of t quantity squared dt. Done. And we don't need our calculator because we can't figure it out because we need to know what a and b are. But that's it, ladies and gentlemen. That is arc length. So hopefully that makes sense to you guys. And I will see you in the next video.